Okay, here comes section 3.3, which is about frequency and phase shift. And so, excuse me, the period of a function is, for periodic functions, is the time it takes to complete one cycle. So a period of a sine wave or a cosine wave is 2 pi. It takes 2 pi units to complete one cycle before it begins to repeat. So that's what a period is, and the units are how long it takes, how many seconds per cycle. So that's what a period is. A period is equal to 1 over f, or 1 over the frequency, and vice versa. The frequency is equal to 1 over the period. So frequency is how many cycles you can complete in a second. So how often that's happening. So the unit of frequency that is often used is called a hertz, and 1 hertz is 1 cycle per second. So what you can see is that period and frequency are inverses of each other. So let's look at a couple of examples. You'll have some homework problems, I think, similar to this, so let's see how this works. Number 1, it says the following table gives the highest and lowest frequencies of 5 common sound sources. Find the time it takes to the given sound to complete one cycle. So they're asking for how long something takes to complete a cycle. They're asking us to find the period. So for number 1, part A, it says the lowest frequency of male speech. What they give us for 1A is the lowest frequency for male speech. So we go over there and we read the chart and we see that for male speech, the lowest frequency is 80 hertz. Okay. What are we supposed to find? We're supposed to find the period. So the period is equal to 1 over the frequency, or 1 over 80. And so when we put that in our calculator, we get 0.125, and the units on this are going to be seconds per cycle, because we take the reciprocal of what the hertz is, and it's going to be seconds per cycle. It takes 0.125 seconds to complete one cycle for the frequency of the lowest frequency of male speech. So B, we're going to do the same thing. It says that the highest frequency of human hearing, we go to our chart and we say, well, where does that fall on the chart? And we say the highest frequency for human hearing is 20,000 hertz. 20,000 hertz. Okay. So what is its period? How long does it take to complete a cycle? So that would be 1 over that. The period is 1 over the frequency, or 1 over 20,000. And so when you put that in your calculator, I just wanted to point this out. Your calculator might kick into scientific notation, so I want to make sure you know how to interpret this. You might get this, 5e minus 5, and you might think that that means an error of some sort. However, it doesn't. It means that it's kicked into scientific notation. So how you interpret this is 5 times 10 to the negative 5. This is what this means when your calculator gives you this. And then if you take this and put it back in a standard form, this means that you're going to shift the decimal, which is currently here, to the left 5 places. So this is going to equal to 0.1234 seconds per cycle. And so that's how long it takes to complete one cycle at that frequency. All right, that's how you would do number 1. Number 2, before we do number 2, I want to introduce these terms: simple harmonic, simple harmonic motion, and then mention some of the applications. So simple harmonic, what a simple harmonic is something that it has this equation. This is a simple harmonic, one of these equations. Y equals to A plus, K plus a sine of bx, where do they want to put this? Plus d, how do they call it? Plus c. They call it different ways. Bx plus c, or y is k plus a cosine of bx plus c. All right. So these can be written slightly differently, meaning the same thing. You can have a sine or a cosine wave. What is this bx plus c? This plus c is new to us. And so what that is a phase shift. Or in regular language, other equation language, that is a horizontal shift. But when we use trig functions, we call it a phase shift. So let me just remind you what this means. If we had, go back to our good friend, the absolute value of x, which is this graph right here. If we had x minus 3, this would indicate a horizontal shift, which is the opposite of what it appears to be. So we would move this to the right 3, and then we would graph it. Or if we had the absolute value of x plus 2, and it was inside there with the absolute value, this is going to indicate the opposite of what it looks like. So we're going to shift that to the left 2, and I do a little bit better job drawing that. And that's what that would look like. So when it's inside there with the function, not outside, this is vertical shift, it indicates some kind of horizontal shift. So I'll show you how those goes. But this is a simple harmonic when something's in this shape. What does simple harmonic motion mean? It means that any object that moves in accordance with this type of equation has simple harmonic motion. If you think about the motion of that, it's repetitive because these are periodic. It's up and down and up and down and up and down. Examples of things that move with simple harmonic motion are the motion of a spring. On our worksheet, we're gonna take a spring. If you imagine you pull a spring down and you let it, it's got a weight on it, you let it go, it's gonna bounce up and down and up and down and up and down. And if you were to measure that movement, what you would get is some kind of a sine wave or a cosine wave is what you get there. Simple harmonic motion. Other examples are in electric current or light waves or music or ocean waves, water waves. Those move according to simple harmonic curves. So those are applications. Let's do this first example with the spring, number 2. It says if the motion of the weight of the given picture has an amplitude of 4 and a frequency of 2, and its position when t is 0 is 4 centimeters above its equilibrium point, find an equation of the form y equals a cosine of bt that describes its motion at any time. Okay, so let's discuss equilibrium. That is when something is at rest. So if you have a spring hanging with a weight on it, the weight's pulling it down, but you just walk up to it, nothing's been happening in a while, it's at rest. But then if you push it up and let it go, it's going to start boinging up and down. Or if you pull it down a certain amount and let it go, it's going to start boinging up and down, up and down, up and down its equilibrium point or its midline point. So let us imagine this. You have a picture on your page, and what it says here is that when t is 0, it's 4 centimeters above. So let's think about that. If this is our xy axis, only x is time, and y is y of t, some function in terms of t. This is saying right here, when t is 0, it's up here at 4 centimeters. This is in centimeters. It's at 4 centimeters. It's saying that it started high. When something starts high, it's not sine, it's cosine. So this is telling us it's a cosine wave, and they even told us that in the problem. They said, write y equals the cosine of bt. Y is equal to a cosine of bt. Well, the amplitude, it's going to go up 4, and then it's going down 4, and up 4, and down 4. So a is 4. Okay. What is left for us to figure out? We got to figure out the period, or what b is. So if we can figure out what b is, then we can write this equation. They gave us enough information to do that. We know, in general, that the period is equal to 2 pi divided by b. That's this b right here. But they didn't come out and say, here's the period. They came out and said, here's the frequency, which is as good as saying, here's the period, because the frequency is 2, right? F is 2. But we know that the period is 1 over F, so that's 1 over 2. So we say, in general, the period is 2 pi over B. For this problem, the period is 1/2. So we say this is equal to 1/2. And we can cross multiply and solve for B. B times 1 is equal to 2 times 2 pi, 4 pi, and this is the B that we put in here. So our equation is 4 cosine of 4 pi t. And so that's how you can do a problem like that. I like that. Let's jump into the graphing now. Now we're going to do some graphs. So with phase shifts, so let us hit it and let's see how this affects things. We learned already how to do reflections and how to do vertical shifts and how the period can change. The last little piece of the puzzle for graphing these kind of waves, these kind of curves, is to handle a phase shift. So let's look at that, a horizontal shift. Number 3 goes like this. We're going to sketch y equals 2 the cosine of x minus pi over 2 over this interval. Pi over 2 is less than or equal to x is less than or equal to 5 pi over 2. We're going to answer these questions. Amplitude, the period, the spacing, the vertical shift, the phase shift, reflection, and the range. Okay. All right, so we've added this to our list, phase shift. So this is new, but we have a new. So this, in general, is the full-blown, what kind of sine wave could we have? We could have this. Y equals 2k plus a cosine of bx plus c. Or y equals 2k plus a times the sine of bx plus c. Now, when our equation is written like this, it's not quite so easy to see what the phase shift or the horizontal shift is. What we're going to do is factor out the b right here, and then we can see the phase shift. So, instead of writing it like this, I'm going to write it like this. The only difference is I factor out that b, and when you factor something out, it's like you divided it by that. This turns into x plus c over b. All right. So it's hard to see with variables, but with numbers it's easier to see. If I say factor out a 2 from here. Okay, pull out a 2. We're left with x plus 2. Can we check that? Yeah, 2 times x is 2x, 2 times 2 is 4. What if there's a fraction in there? What do we do with this? Oh, I meant to write it like this. If I factor out a 2, sometimes this trips people up, but if we factor out a 2, it's like you divided it out. 1/2 divided by 2 is 1/4. If you're unsure, multiply it back together. 2 times x is 2x. 2 times 1/4 would be 2 over 4, which would be 1/2. So that's what you're going to be seeing. Okay, I could do the same thing here, but let's just get started graphing this and see how it goes. The first thing I'm going to do is rewrite this. If I'm going to say what is b and what is a, let's pull those things out. And if I need to factor out a b, I will do that. So let's just make a little comparison here. This one's going to be graphing in purple. So let's do this. Y is k plus a cosine of bx. Okay, if I factor out, what's in front of the x here? It's a 1. So if I factor out a 1, it's going to look exactly the same. So I don't have to worry about factoring out the b in this particular case. I can identify everything. What is k? Do I see a plus something or a minus something? No. K is 0. That means that there is no vertical shift. Okay. What is A? I don't see anything. So that means it's a 1. That is what's holding this equation on the board. The amplitude is 1. Is it negative 1? Is there a reflection? No, it's positive 1. So there's no reflection. All right. What is the period? The period is 2 pi over b. So it's 2 pi. What is b? B is whatever I see in front of this x. And that's another 1. 2 pi over 1, so it's just 2 pi. What is the spacing? It's the period divided by 4, so it's 2 pi over 4 or pi over 2. This is what I'm going to split stuff up into. How about a phase shift? If I factor out that 1, okay, let's do that. It looks exactly the same. And so whatever I see here after I factor it out right there, that's my phase shift. So it's a horizontal shift opposite of what it appears to be. So if this is minus pi over 2, that would normally mean left, but it's opposite. That means we're going to shift to the right. The phase shift is to the right. Pi over 2. That's how we think of that. All right, we'll do the range at the end. Let's go ahead and graph the sky. So, goes like this. X, Y. How are we supposed to split up our axis? The spacing is pi over 2. We're supposed to go from pi over 2 to 5 pi over 2. Okay. Then let me move my y-axis over a little bit then. Okay. Okay. So, pi over 2 is the split. So let's see. 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2. All right, and we can go further or further back because we know it goes on forever, but we'll just do what they said to do. What's the amplitude? It's 1. Okay, so let's mark that. 1, negative 1. Is it reflected? No. What graph is it? Cosine. That means we start high. All right, we start high. Normally we would start at 0, but there is a phase shift. So this means instead of starting at 0, we're going to move to the right pi over 2, and this is where we will begin our graph. So this means instead of starting high at 0, we're going to start high at pi over 2, and then we're going to do our pattern. Middle, low, middle, high. And this is the graph. We could make it go on or back. So what is the range? The range is from -1 to 1. All right, that's it. Here's number 2. Number 2 says, let me double check. Oh, let's call out the midline. What was the midline for this? Was there a vertical shift? There wasn't. So the midline remains the x-axis. So that is y is 0. Okay, cool. This is number 4 on our sheet, and it says, sketch 2 y equals to 2 sine of x times pi minus pi over 2. All right, from -2 to 2. Here is my grid. All right, let's see what we can get going here. Maybe I want that longer. We will see. We will see. All right. So what do we know here? Let's start picking this guy apart. Do you see a plus k? Plus or minus anything? I do not. So that means no vertical shift. Okay, so this means, where's my vertical shift? So there's not any vertical shift. No vertical shift. Okay. What is the amplitude? The amplitude is whatever I see in front of the whole thing. This is where my A is. So the amplitude is 2. Okay. Is it negative? No. So that means also there's no reflection. Okay. What is the period? All right, what do I find in front of my x? Well, this time we also have commutative for multiplication. So if I write x pi, this is exactly the same thing as pi times x. So if you want to rewrite it like that, that is completely fine. So b is pi. So the period is going to be 2 pi divided by b, or 2 pi divided by pi in this case, or 2. The period is 2. The spacing is the period divided by 4, or 1/2. That's how I'm going to mark up my x-axis. Now, does it have a phase shift? Yeah. Do you see this stuff in there messing with it? Phase shift, horizontal shift. Before I can spot what it is, I need to factor out that pi. So here's a little bit of work I have to do. Factor out that pi. When I factor that out, it's like dividing it out. I get x. If I divide pi over 2 by pi, I just am going to be left with the 1/2 minus 1/2. You can multiply this back together to make sure this agrees, but that's what it will be. So this tells me I have a phase shift of, it says negative 1/2, opposite of what it appears to be, so I'm going to shift it to the right. To the right by 1/2. Okay, there we go. Let me make sure I'm doing that right. 1/2, 1/2. No, okay. So let's start cutting up our axis with the spacing. Let's go to the right. And we got to go all the way to 2. So we've got 1/2, 1, 3/2, 2. 1/2, 1, 3/2, 2. Negative 1/2, negative 1, negative 3/2, negative 2. All right. So this is a sine wave, and it starts in the middle. Okay. How high and low is it going to go? It's going to go up 2 and down 2. Up 2 and down. Well, let me try to make this a little bit better. Let's say this is negative 2 and this is negative 1. I'll make my scale a little bit better. This is 1 and this is 2. Okay, all right, there we go. Now, what else am I trying to say? Let's see, let's make sure. Got the amplitude, we got the spacing. Is there a vertical shift? No. Is there a phase shift? Yes. Okay. So that means sine normally starts in the middle at 0, but we're going to go over to 1/2, and that's where we're going to put our 0 point. So we're going to start here. It is not reflected, so that means the next move is going to be middle, high, middle, low. And then middle, high, middle, low. And then so if we went backwards, it's going to go low, middle, high, middle, low. So let me connect the dots here, and then let me make sure I'm happy with this graph. And it lands low at 2 and low at negative 2 and up at 2, and I'm okay with that. Where is our midline? The midline is still the x-axis, y equals to 0. What was our range? Our range is negative 2 to 2. What I notice is this looks very much like a cosine wave that's been reflected. So you can get a sine wave out of a cosine wave just with a phase shift. That's what is true. All right, so let's go ahead and do number 5 and number 6, and then we'll be done with this one. All right, number 5 looks like this. We want to sketch y, this is 5, equals to 4 minus 3 times the sine of 4x plus pi over a 3-period interval. Okay, so when it says that, we choose where we want to put any 3 periods. Okay, so that's totally up to you. So we're going to call out the amplitude, the period, the spacing. Is there a vertical shift? Is there a phase shift? Is there a reflection? And what is the range of this guy? All right, so here we go. Let's see if we can figure this one out. This is number 5. Is that right? The one we just did? Okay, and we can figure this one out. We just got to pick it apart. All right, so this one is a sine wave. Okay, so we're looking at something like that, and we see 4 minus 3 sine of this. So this 4 right here is this k value right there. Okay, so we do know right off the bat that there is a vertical shift. Vertical shifts are what they appear to be. So since that 4 is positive, it simply means it's going to be shifted up 4 units. So let's go ahead and mark that. This is what K is. This is K. All right. So is there a vertical shift? Yes, it's going to go up 4. All right. What is the amplitude? Well, it's A. It's whatever's in front of the sign. So it's 3. It's the absolute value of that. Is it positive or negative? It's negative. So yes, there is a reflection. What is the period? The period is 2 pi over B, but B is 4 in this case. So it's pi over 2. What is the spacing? The spacing is the period, pi over 2, divided by 4. You can do a keep, change, flip, and you will find that this is equal to pi over 8 is our spacing. Is there a phase shift? Yes, there is, but I cannot quite tell what it is with that 4 in there, so I factor that guy out. So this is going to be, if I rewrite this, this will be 4 minus 3 times the sine of 4, factor that out, times x plus pi over 4. So it's like a division. If you multiply it back together, you can see that we have the same thing. So now I can spot my phase shift is to the left, pi over 4. Left pi over 4. Okay, and we'll deal with the range at the end. Let's start splitting up our interval. It doesn't say where we have to do it. It just says 3 periods. So 1 period is pi over 2. So let's see. Let me just start marking it up. This is pi over 8 plus another pi over 8 is 2 pi over 8, which is pi over 4, plus another pi over 8 is 3 pi over 8, plus another pi over 8 is 4 pi over 8, pi over 2. I'm going to go 4 or 5 more. 1, 2, 3, 4, 5. I'm going to go backwards. 1, 2, 3, 4. Okay. So this is pi over 2. This is the next one will be 5 pi over 8. The next one will be 6 pi over 8 or 3 pi over 4. 7 pi over 8. 7 pi over 8. 8 pi over 8 is pi. Oops, I'm missing. This is, let me get some. 1, 2, 3, 4. 1, 2. This is 7 pi over 8. This one is pi. This is 9 pi over 8, if I go that far. Okay, backwards, negative pi over 8, negative 2 pi over 8, or negative pi over 4, negative 3 pi over 8, or negative pi over 2. All right, that should get me 3 periods on there. Let's see, the amplitude is 3. 1, 2, 3, 1, 2, negative 3. All right. There's a vertical shift. We'll handle that at the end. There is a phase shift. So this is sine, which I start in the middle, but at 0. But if it's shifted to the left by pi over 4, I go left pi over 4. So if I'm at 0 and I go left pi over 4, here, this is where I'm going to start at my 0, right there. Okay, so if I do that, then I'm going to just follow my pattern. Is it reflected? Oh, it is reflected. We have a lot to keep up with in this problem. So instead of going up at the next move, I'm going to go down at the next move. So, ready? Let's just start laying some points out. Middle, low, middle, high, middle, low, middle, high, middle, low, middle, high, about right there. Okay. We can go backwards. Let's see, high, let's see, low, middle, this will be high, middle. Okay, so then we can connect our dots. Okay, all right, we know it goes on. Okay. Now we have to deal with the vertical shift at the end. Up 4. So what I'm going to do is I'm going to go to my x-axis and I'm going to add 4 to every unit right there. So -3